Hello, welcome to Algebra 2. We're still on Unit 1. We're going to be doing Lesson 13 today. And today, your learning target. You should be able to say, I can classify expressions by identifying their terms and use properties of real numbers to solve equations. You should be able to classify expressions according to their terms, identify how many terms are in an expression, and you should be able to use the properties of real numbers to solve equations. I apologize if you hear some shouting in the background. My daughters are playing Castle Crashers in the room next door, and I've asked them not to shout, but when you're playing Castle Crashers, you just feel like you got to shout. So I apologize if you hear that noise. I can hear it, but hopefully the microphone isn't sensitive enough to pick that up over here. So here we go. Some basic definitions. Let's talk about some basic definitions here. A variable. A variable is a quantity that is unknown. When we talk about x, we often talk about that's a variable. Quantity that's unknown. We don't know what x equals. We want to find out. It's unspecified. Or more often when we talk about functions, the value of x can change within the context of a problem. More often, variables are represented by a letter or a symbol. So you've seen that quite a lot. Term. What is a term? A term is a single number or combination of numbers and variables using exclusively multiplication or division. This definition will expand as we introduce into higher level functions. And then expression. What's an expression? It's a combination of terms using addition and subtraction. So, exercise 1, consider this expression. Why is this an expression? Because it's a combination of various terms. We have a term here. That's one term, 2x times 2 times x to the second power. And we have another term here, 3x. We have another term here, negative 7. This expression has 3 terms. And the first question asks, how many terms does this expression contain? It contains 3. 1, 2, 3. All right? These two terms are different because this one is being multiplied by x squared. This one's different from this one because it's times x. And this one here is just times 1. No x. So it's 3 terms. B, evaluate. Evaluate this expression without your calculator when x is negative 3. Can you do this in your head? If you need your calculator, that's okay. I'm trying to get us towards being able to do some of this in our head so it becomes faster, it becomes easier. It'll feel less bulky if we can do some of this in our head. But if you don't want to, use your calculator. That tool is useful. It's a lifesaver. It's your friend. Use it if you need it. Let me try to show you how I would do this. Evaluation. Now, do you remember what evaluation means? Evaluate means we are going to plug this in and find out what the output is for this function. So if I plug in negative 3 every time I see x in this function, I'm going to get 2 negative 3 squared plus 3. Again, I see x, so I got to plug in negative 3 in here, minus 7. All right? Do we see what that? Every time I see an x in this function, I'm plugging in negative 3. Now I just have to simplify this equation. Again, I don't have to pull up my calculator. If you want to use your calculator, you can plug it in just like this, and it'll work fine. Your calculator can do all the heavy lifting here, but we don't need it. Negative 3 times negative 3 is positive 9. That's what negative 3 squared means. It says take negative 3 times it by itself once. Or, yeah, take it by itself once, right? So it'll be negative 3 times negative 3. Does that make sense? I'm taking negative 3 twice, times it by itself once. Okay? So now I know this is 9. I need to drop that 2 down. Negative 3 times 3, negative 3 times 3 here. Well, I have a negative and a positive, so I have a negative number. And it's going to be 3 times 3 is 9. So 3 times negative 3 is negative 9, negative 7. So I've simplified it down this. Let me simplify it down one more line. 2 times 9, 18, negative 9, negative 7. All right. This is where you could pull out your calculator. You could pull out your calculator there too. But let's think. 18 minus 9. What's 18 minus 9? That's 9, right? 18 minus 9 is 9. 9 minus 7 is 2. So what we could say, if we had a name for this, if we called this the f of x, we could say if this is the f of x, we could say the f of -3 is equal to 2. F of -3 is equal to 2. And last but not least for this warm-up, what is the sum of this expression with the expression 5 times x squared minus 12x plus 2? Pause the video here, see if you can do this one on your own. All right? Pause it now. All right. Hopefully you paused the video and you tried this, because by trying, and if you succeeded, good. You've practiced a skill successfully if you succeeded. If you tried and failed, good. You know what? Because you've opened up that filing cabinet in your brain, and now you're like, I don't know how to do this. Your brain is opening up filing cabinets. Where is the information? Where is the information I need to do this? I don't remember. You've opened up the cabinets you need. Now we need to put the right stuff in it this time. Then you'll have it next time your brain opens up that filing cabinet. All right, so we're going to have 2x squared plus 3x minus 7, and we're going to add 5x squared minus 12x plus 2. Again, sorry for that shouting if that's coming over the microphone. 5 and 2 is 7. I'm going to these are like terms, right? I'm going to combine like terms to make this. I'm going to simplify this expression by combining the like terms. These are both being multiplied by x squared, so I can combine them. 5 plus 2 is 7. Get 7x squared. All right. Now this is a like term. This is a like term to that. They're both being multiplied by x. So -12 plus +3 is -9. Use your calculator if you don't want to do the mental math there. That's okay. And then 7 being multiplied by 1. No variable next to it. I can combine -7 with +2, -7, +2, -5. That's the sum of these two expressions added together. In the lower right-hand corner of this paper, please give me the smiley face reflection. Smiley face for this was easy. Frowny face for, oh, I'm confused. I don't know where we are. I feel lost. And something in between, like, this feels familiar. I feel okay, but I need more practice. It's not easy for me yet. That's okay. We learn where there's struggle. We learn when it's tough. We do what's easy all the time. We're not learning. All right, we're going to talk about like terms. The definition. 2 or more terms that have the same variables raised to the same powers. Those are like terms. In like terms, only the coefficients, the numbers multiplying the variables, can differ. Only the numbers multiplying the variables can differ. The powers, the exponents, the variables all have to be the same. Here's exercise 2. Most of you learned to add two like terms. You simply add the coefficients and leave the variables and the powers unchanged. And let's think about why this works. Here's an example. Why would this work? If we have this expression here, 4 times x to the second times y plus 6 times x to the second times y, we could break this down. We could break this expression down into x squared times y times the expression 4 plus 6, right? Because this times 4 would give me this. And then this, distributing that again twice over, distributing it once, distributing it twice, would then give me this expression. These two sides, these two expressions are the exact same, are equivalent. They're equal to each other. They're just in different form. Well, what's 4 plus 6? 4 plus 6 is 10. We can add 4 plus 6, right? We know how to do that. Well, then, if I know that 4 plus 6 is 10, and I know that this times this gives me this, then 10 times this gives me this. Which means I can simply add, since I see all the coefficients are the same, I could simply say this is 10, 4 plus 6 is 10, x squared y. This is what we get. That's kind of the explanation. Or maybe to simplify this a little bit more, what if x is 2? Let's say x equals 2. And let me say I have an expression 5x plus 3x, and it's going to be equal 21. 24. No, 16. Sorry, trying to create an equation on the fly. Create an equation on the fly here. All right, so let's think about this. If x is 2, 5 times 2. 5 times 2 is 10. If x is 2, 3 times 2 is 6. That's 16. 10 plus 6 is 16, right? Well, what I could have done was just added the 5x and 3x together as two coefficients. 5 plus 3 is 8. Well, if x is 2, x times 8 is 16. See how that doesn't matter which way I do it? Whether I plug that number in one way or the other, or if I add the like terms together and then multiply it out, it works every time. So, for each of the following expressions, state the number of terms. So pause the video, take some guesses, make some risks. This is where the learning happens. Pause it now, give it a shot. Okay, hopefully you paused the video and you gave some of these a shot. Let me show you how to do this. There's one term here. There's one term here. Notice how they're being multiplied. There are two different things being multiplied together here. This doesn't have any variable by it, so I have two terms here. How many terms in this expression? Well, I have one term, x to the third, another term, x to the second, another term, 8x, and negative 2. That's 4 terms altogether. Over here, I got to just be careful. I'm looking for the right the right exponent. So this is one term to the x 1/2 times x times y to the fourth. That's one term. I have another term here. It's negative 2 times x to the second times x to the second. That's another term. And I have 7 times x times y. 3 terms in all. All right, feeling good about that? How about at this point, you give me that lower right-hand corner smiley face reflection. Tell me if this is smiley face easy, frowny face confusing, or something in between. I just want to know how we're feeling about like terms and counting what terms are in an expression. I might have to pause the video and tell them to stop yelling. All right. They're going to shout again any minute now. It's hard to control yourself while playing Castle Crashers. All right. Simplify each of the following expressions by combining like terms. Be careful to only combine terms that have the same variables and powers. So we're going to simplify these by combining like terms. All right. So where are my like terms? Well, I see an x to the second and an x to the second. I can combine those. They have the same variable to the same exponent. So that's 7x squared. 5 plus 2 is 7x squared. Now I have one of these, negative 2 times x, and one of these, right? 8 times x. So I'm going to combine those. 8 plus negative 2 is positive 6x. And they're shouting again. All right, and negative 8, and I have I kind of already underlined it. I didn't mean to underline it that much. That's what you get. We're using crayons. Negative 1 and negative 8. I can combine those to negative 9. There. I've simplified this according to like terms. Pause the video. See if you can do the same thing to the next one. All right, give it a shot. You can do it. Well, hopefully you've unpaused the video at this point. Let's go over it. Hopefully you did great. If you didn't, that's good too. Because if you didn't get it right, you're now going to learn how to get it right, okay? X squared and x squared together, all right? Now, remember when we do this, we pretend that's a 1. There's always a 1 in front of every variable, right? Anything times itself. 1 times anything is just itself. We haven't changed anything by putting a 1 in front of there. That's the number we need to think about when we see just negative in a variable. So negative 5x squared and negative 1x squared is negative 6x squared. Now I'm looking for just the variables that are being times by x. There's 1. There's 1. I have negative 2 here, negative 2, and a positive 7. We combine those together. Negative 2 and positive 7 is positive 5x. I know those negatives can throw people off. Use your calculator to check your work. And last but not least, I have positive 10. I have positive 5. Together, that's going to be 15. How'd you do? Did you do good? Excellent. Either way, we learned, we practiced, we're improving, we're getting better. You're awesome. Keep going. Let's talk about the properties of real numbers. All right. One property of real numbers, we call it the commutative property. In the commutative property, which we talked about, was that last lesson? Yeah. Talk about the composing functions being commutative. A plus B equals B plus A, right? It doesn't matter what these numbers are. 1 plus 2 is the same as 2 plus 1, right? Addition is commutative. Addition is commutative. I can switch the order, and I get the same result. Same thing with multiplication. Multiplication is commutative. 3 times 5 is the same thing as 5 times 3. It's both 15. Doesn't matter. Multiplication and addition are commutative. Now let's talk about the associative property of addition and multiplication. The associative property means I can associate these differently. 1, 2, 3. 1 plus 2 is 3. 3 plus 3 is 6, which will be the same thing as if I did 1, 2, 3, and I added 2 plus 3 together to give me 5, and then added 1 together to give me 6. Either way, I get 6 with addition. Same thing with multiplication. 1, 2, 3. 1, 2, 3. I'm going to get the same thing if I multiply 2 times 1, that's 2. 2 times 3 is 6. Or if I times 2 times 3 together to get 6, times it by 1 to get 6. Either way, I get 6. The associative property of addition and multiplication. And now the distributive property. The distributive property of multiplication and division over addition and subtraction means that a plus b divided by c is going to be the same as a divided by c plus or minus b divided by c. Also, when we talked about distributing across parentheses, c times the expression a plus b, a plus or minus b, is going to be the same as c times a plus or minus c times b. Okay, so now when we've reviewed commutative, we can switch things around in the order which we multiply or add them. That's not true for, remember, this is addition and multiplication for commutative. It doesn't work for subtraction and division. So keep that in mind. This commutative property only works for addition and multiplication. Associative property only works for addition and multiplication. Distribution kind of is a little bit of a blend, but we need to be careful how we use that too. With commutative, I can switch the order with multiplication and addition. Associative, I can associate them differently with parentheses. It won't matter with addition and multiplication. And the distributive property of multiplication and division over addition and subtraction, that means I can distribute across parentheses. That means I can break up rational expressions into component parts. All right, let's talk about exercise 3 now. We're 18 minutes in. The procedure for simplifying linear expressions. So we have this expression here shown right here. State the real number property that justifies each step. So I do want you to be able to identify the properties of real numbers and be able to write them down, because this is tested on the Regents every now and again. Usually there's at least one question that involves this, if not two, and sometimes it'll look a lot like this where you have to justify step by step. All right, so let's see. Here's my expression. I have parentheses, and then the parentheses got changed. I no longer have my parentheses here. Let's see what happened. My 8 got distributed to here and to here, because I have, okay, so this 8 getting distributed across my parentheses. Here I have my 8 times 2x. Here I have my 8 times 3. Here I have my 5 times the 3x, 5 times 3x. Here I have my 5 times 1. So what's happening here? This is the distributive property. Oh, I'm going to cough again. All right, so this first step is the distributive property because as you can see, I'm distributing the 8 across parentheses. Now, as you can see, I'm adding parentheses back in here. And what I'm doing is I'm taking a parenthesis and I'm putting it here, and I'm taking a parenthesis and I'm putting it here. And then I'm already multiplying these together. This becomes 24. This becomes 5 over here. So what's the property of real numbers that allows me to put parentheses in here and it won't matter, won't change anything by associating the numbers differently? It's the associative property. Associative. Sorry, start going into cursive once I start writing fast. All right, which gives us this right here. All right. Now that we have this right here, notice how the order of what's being added got changed. This 15 went over by the 16 here, and this 24 got moved over by the 5 here. What does it mean when we can switch the order of addition and it comes out fine? It doesn't matter. It's the commutative property. Commutative property. Commutative property. All right. All right, so now what happened here? Now in this step here, I am breaking up the 16 and the 15 away from the x. I'm putting parentheses in here. What's going on? Well, what's going on is I have this right here has got my c times a plus c times b. All right, I got my variables here. I can combine these like terms, and I can stick x out here. This is this distributive property. These expressions will be the same no matter what. I can break this. I can take this x out. I can now add 16 plus 15, which gives me 31. I can now add these together and put them in parentheses. And so now here I've just added some parentheses to say I can add these together by associating them differently. So this is associative because I'm adding these parentheses, making this 29. That's all the steps, all the properties of real numbers which are used to simplify this expression. Lower right-hand corner, give me the smiley face reflection. Tell me how you feel about what we just did. Again, smiley face, easy. Frowny face, confused. In between means we're learning. All right, we're on for the check for understanding. I have to pause every now and again. I know that might, suddenly I'm in a different position or something. It's because I'm coughing. I'm still getting over this bronchitis. All right, classify each of the following as either a monomial with a single term or a binomial or a trinomial. So if it has one term, it's a monomial. If it has two terms, it's a binomial. If it has three terms, it's a trinomial. Like for instance, I'll do two of these. I'll do two. I will do this one. This one is a binomial. Because I have one expression up here, I have another expression down there. All right. Let me do another one. This one here is a trinomial. Why? Because I have one expression here, sorry, one term here, one term there, and one term there. The whole thing is an expression. Make sure we use our vocabulary words correctly. You do the rest for that check for understanding. Let me see about this one. Use the distributive property first and then combine each of the following linear expressions into a single equivalent binomial expression. Well, let me do one of these and I'll have you do the other. I'll do B. 2 times 10x. 2 times 10x is 20x. 2 times 1 is plus 2. I now gotta like take this whole piece together and distribute that negative. I gotta be very careful to distribute that negative over each piece, each term here. Piece of this expression. Negative 3 times positive 4 is going to be negative 12x. Again, distribute the negative with that 3 to both terms. This is a common mistake students will do. They'll only distribute it over to one and not to the second part, second term in the binomial. That won't work. That violates that distributive property. Negative 3 times negative 5. A negative times a negative gives me a positive. 3 times 5 is 15. I now combine my like terms. I have one like term here and one like term there. Let's see, 20 times x plus 12 times x is going to give me positive 8x. And positive 2 and positive 15 give me positive 17. That's this whole expression distributed and simplified. I want you to do the other one. Pause the video here, finish your work. After you're done, give me the reflection. What's working in the classroom? What's working in the videos? What's working with your learning? What's working with you? What's being successful? What's successful today for you? And then tell me what we can do to improve everything. What can be better with the videos? Maybe no screaming in the videos. maybe what can be improved is you need to get more sleep or have better breakfast or whatever you think. You need to always be thinking about how we can do better. All right? Myself as well as you. We're going to get better together. We're a learning community. So pause that video, work on that check for understanding. I'm going to move on to the homework, which we'll take a look at. Oh, the screaming's getting loud. I might have to talk to them again. All right. Where to the following is equivalent to the expression 2 times the term x minus 6 plus 4 times the term 2x plus 1 plus 3. We're going to need to distribute things out, find out what this simplifies to figure out what we're looking at here. All right, well, let me start distributing. 2 times x. 2 times x is just 2x. 2 times negative 6 is negative 12. Now, for those of you who don't like this method, this is what's called the FOIL method. I've also introduced to you the box method. So what you could do is you could say 2 here, create a box, and then you have x here and negative 6 here. And so now it's 2 times x is 2x. 2 times negative 6 is negative 12. You can write that out. That's a perfectly legitimate way of doing this. The next one, you would say, and you can do it the box horizontal too. You can create a box like this. You can put 2x plus 1 in it. You can say 2x times 4 is 8x. 4 times 1 is 4. And then you could totally add 8x plus 4 to your thing. It would be the same thing as if we did this and said, what's 4 times 2x? 4 times 2x is 8x. What's 4 times 1? 4 times 1 is 4. Exact same thing. Use the box method. For those of you who don't like this method, this is what I use. This is what I like. Pick a method and stick to it every single time because that'll give you reliable results. We want to make you like a mathematics machine. You just spit these out. We want to get it to where you're playing piano and not even thinking about it. You're doing the math without your brain is engaged. But there's so many of the little tiny stuff that's going on that you're doing automatically. Almost like when you're driving a car and you don't even realize, you realize the last 5 minutes you don't even remember driving down the streets. You don't even know how you got home. Driving became so automatic for you that eventually it's almost like your brain isn't really engaged. And again, I don't want to go into the neurology here, but it has to do with our habits are ingrained in our brain in a very different way than our conscious thought is. That if we create habits, they are learned differently than like straight up content. They're remembered differently. You can have brain damage and still remember your habits. There's a story of a guy who, while he couldn't remember anything that happened to him after he had a tragic injury to his brain, he couldn't remember his doctor's his surgeon's name. He still remembered his wife and all his past memories. He couldn't make new memories though. However, even though he couldn't make new memories, if he did things habitually after that injury, his brain could remember the habits. He could remember to, like for instance, make a new breakfast. If he did it over and over and over again, even though he wouldn't remember how to do it, he could do it, even though he couldn't tell you how he does it. Because our brains are funny that way. That's where I want to get you in terms of this math here. All right. Now we're going to add our like terms. We have 10x. We have combine our like terms. Negative 12 and 4 is negative 8. And none of these look like my answer. Oh no. What do I do? Do I give up? Or do I think, how can I make this work? I notice that All of these are similar, and they have parentheses and a number out in front. I wonder how to break this expression up in a way that makes it look like one of these. Well, I need to pull a number out of this. So I could pull a 2 out. Let's see if I pull a 2. What happens if I pull a 2 out of here? 10 divided by 2 is 5. So 10 divided by 2 is 5x. I can pull a 2 out of 10x. I can pull a 2 out of negative 8 and make it negative 4. Is this any of my choices? No. None of my choices look like that. What other numbers could I pull out of 10x minus 5? Well, I could pull out, sorry, I had a cough there, and then I started doing a little work without turning the video back on. So I coughed, and I realized, wait, okay, this doesn't seem to be working. What error have I made? And I looked, oh, wait a minute, I forgot this plus 3. I forgot that plus 3. I'm just being careful, moving slow. This plus 3 ought to have gone over here. When I got 10x minus 8, I should have added 3 here, which should have given me 10x minus 5. Okay, now let me pull a 2 out of 10x minus 5. Or I can't pull a 2 out of 10x minus 5. Let me pull a 5 out of 10x minus 5. I'm going to pull a 5 out. 10 divided by 5 is 2x. If I was to redistribute this 5 to the 2x, I'd still have 10x. I'm still preserving everything. These equations are going to be equivalent. I'm just pulling a 5 out of the whole equation. Negative 5 divided by 5 is negative 1. Do any of our answers look like this? 5 times 2x minus 1. And yes, one of them does. All right? That's how to do that one. This one here. So for each step, I want you to give me the commutative, associative, or distributive property for each step here. What do you think is going to go on? You know what? I'm going to let you do this one on your own. We're at 32 minutes. I think we're going to wrap it up for the day. Do this last one on your own. I think you can handle that. Give me that smiley face reflection on the homework. Easy, hard, something in between. Have a great day. Hopefully you could say that you can classify expressions by identifying their terms and use the properties of real numbers to solve equations. If you can say that, mission accomplished.